By the time you finish watching this video, you will be learning concepts like regression, k-means clustering, unsupervised learning, reinforcement learning, one-hot encoding, feature engineering, and so much more. So without wasting any more time, let's jump into the screen. Now let's talk about regression model. For that, let's take an example of real estate that we have already spoken about. So what happens in real estate is if there is this is a price graph and this is a size graph. So with the increase of size, there is highest probability that the price is going to get increased, right? So when we train a model with regression, what happens? The output is not fixed, because if the size gets increased, the price also going to get increased most probably. So this is going to predict output, not it cannot be classified into any particular category. So it's going to predict output, different output. So for that reason we use regression models. So there are basically two popular models that we're going to discuss about. One is linear regression and one is polynomial regression. What linear regression does it? This actually works on a straight line mathematical formula. So what happens if this is our graph? It is going to predict. So these are the data. Let's say this is the size of the house and the price of the house. This is good. This is the price of the house, and the model is going to create a straight line around this. So next time if you're going to give the size, let's say we're giving the size here, it's going to predict the output here. So this is, let's say we're going to do size graph and this is price graph. So this works on a straight line, and the formula that works is y equal to mx plus c. This is the formula of a straight line. Let's take another example to understand this y equal to mx plus c. So for that, what I'm going to do, I'm going to assume we're going to do a t-shirt printing business. So for the t-shirt printing business, let's say we're going to print 10 t-shirts. So y is going to decide the amount that we're going to spend on the printing t-shirt. X is equal to the number of t-shirts that we're going to print, and c is constant, which will represent the amount that is needed to start the machine. Let's say 100 rupees is needed to start the machine, whether you print one t-shirt or you print 1000 t-shirt. This is the minimum amount you need to start a machine. So for that, let's say the t-shirt print is 5 t-shirt first. So 5 t-shirt, if we're going to print, so this is going to be this, m is going to be the price of t-shirt. Let's say 50 rupees per t-shirt it's going to charge. So 50 into 5 plus constant is 100 rupees. So here going to get 350 rupees. So let's say 5 t-shirt, the price is going to be somewhere, this is 350 rupees. So for the 5 t-shirt, the price is, let's say here it's coming 350 rupees. So similarly, if we'll go to 10 t-shirts, so this number will be 10. So this is going to be 600, right? So this is going to be 600. So 10 t-shirt, yeah, 600 rupees. So the price here, the price will come, let's say this is 600, this is going to come 600. So like that, 5 t-shirt, 10 t-shirt, like that, if you do, it's going to make a curve like this. And once you finalize training the machine, let's say you're going to ask how much it is going to cost me to print, let's say 1000 t-shirts. So what the model is, because the model have data for 5 t-shirts, 10 t-shirts, 100 t-shirts, like that, the straight line it has already created. So with the 1000 t-shirts, it's also going to predict somewhere here the price, and by that we're going to see the result of the predicted output. So that is how the linear regression works. Now what polynomial regression does, it instead of straight line, it creates a curve. So let's say our inputs are here, 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 input output. So it's going to create a curve. For an example, let's calculate the growth of a human child from 1 year to 18 year. So what happens in the initial year? Let's say the child is eating 1 kg per year and the growth is, let's say, 500 gram per year. But initially, if you see, 1 kg will be next year, let's say 2 kg, and the growth will be 1 kg. And similarly, it will go. But after some time, let's say after 10 years or so, the food will go, let's say, per year, let's say it's going to be go in ton. Let's say 1 ton it is hitting, but the growth won't be similar to how it is linear in the first place. So in that case, what happens, it creates a kind of curve. So if you later, in the later case, if you want to input the age of the child, it's going to create a curve, and from that curve it's going to predict this is going to be the growth of a child, or this is going to be the weight of the child going forward. So this is how a curve is being made. Now what is the formula for this? Is formula is y equal to m1x plus m2x square plus m3x cube plus c. So this is the formula for the curve, and this follows polynomial regression, and here we have linear regression. How we predicted the accuracy of classification model using confusion matrix. Similarly, for regression model, we have methods to predict accuracy such as MAE, which is mean absolute error, MAC mean squared error, RMAC root mean squared error, R square coefficient determination. Now there are mathematical formulas which is a little complex to understand, so I have written down the formulas in simple words. First you need to understand this. Later, if you feel like you want to go to mathematical formulas in detail, you can definitely search and go. So what is mean absolute error is, it's the sum of absolute value of actual output minus predicted output by total number output. So how many actual output whatever we are getting minus predicted output what we are getting, and sum of all this by total output, how much we are getting. Now MAC is the squared of this sum of actual output minus predicted output squared divided by total number of outputs. SA is sum of absolute errors, is just the sum of absolute value of actual output minus predicted output. The absolute value is being written to remove the negative signs. Absolute value will make it positive. Now this is R square score coefficient of determination, which is 1 minus sum of actual minus predicted squared divided by sum of actual minus average of all actual squared. So these are basically the methods to predict the accuracy of regression models. Now by far whatever discussed are into supervised learning. Now let's come to unsupervised learning. Now what makes unsupervised learning different is, while training the all supervised model, we just give the feature, we do not give the label. So outputs we do not give, we only give the features of the data, and we expect the unsupervised model to predict the output. Now what does it predict? It generally used for clustering. Let's say we have few data, we have to divide into two groups. So those kind of problems we can solve using unsupervised model. Let's say we have mangoes and banana mixed together. So what it can learn is, it can group into mango and other is into banana. There are different models available for this, but one of the popular model is k-means clustering. K-means clustering. So this does what? This exactly does what I said. If you're going to give different inputs of different things, let's say age and weight, let's consider in that way, age and weight, and let's say we want to divide into two categories. This is the group 1 and this is the group 2. It's going to categorize into two different categories. Now this also does math entirely into mathematics, so they calculate average and they push the median of whatever it is calculated. There's a mathematical formula. If you want me to create a video of k-means clustering separately, you can tell in the comment section. I can create a separate video how k-means clustering works. Now, how you measure accuracy of such models that does the grouping? You go for the method compactness and separation. Compactness means the groups, let's say first, this is first group and this is second group. Now the elements in that group that are being formed, how compact they are, how close they are. On the basis of that, you're going to measure the accuracy. And the groups, let's say this is first group, second group, the distance between these two groups are how long, how means how this is a group of apple and this is group of banana, how different it is from each other. So on the basis of that, accuracy is being measured. The formulas are quite mathematic. If needed going forward, we'll go in details, or else we won't go in details, because that is not much necessary unless and until you go deeply into machine learning and data science. Now let's talk about reinforcement learning. Now in reinforcement learning, what happens? We provide the model with features, but we don't provide the labels. Now on the label part, what happens? We just give whether the result is correct or not correct. So if it is correct, the model proceeds with the same pathway. If it is not correct, the model changes its behavior. If I talk about example, let's say we have a robot whose work is to lift a bulb, the electric bulb it's going to lift. It's a robotic arm. Okay. Now, initially, if we train the robot with reinforcement learning, so we just provide, see this, the ball is just going to lift. So it doesn't know how much pressure it's going to apply. So if it is applying a hard pressure, the bulb is going to get broken. And while the bulb get broken, we say this is negative. From this, it understands that it needs to optimize itself and it needs to reduce the pressure. So if it is too sharp, maybe ball is not getting lifted if it is just not holding properly. So in that case also, if we say negative, it's going to increase its pressure. Similarly, it's going to find a point where it's going to see the exact strength and pressure that is needs to apply to lift a light bulb in the robotic arm case. And this kind of learning is called reinforcement learning. Now let's talk about dimension and cursive dimension. What is dimension is the features that we provide are called dimensions. Now, if the data has so many dimensions, doesn't necessarily be a good input for a model. Doesn't necessarily true that if it is being trained with many dimensions, it's going to predict good output. That statement is not true. It has to find a balance between what are the necessary inputs that is needed to get trained and to predict the corrected output so that accuracy will be high. For example, let's say we are playing cricket inside a field. It's a small field. So inside playing cricket, if someone hit the ball, it's going to stay here and it is easy to find the ball. But if you're going to play in a place where there are a lot of houses, and it is the area is big, and if someone hit the ball and it flies somewhere, it is very hard to find. Here if you see, this is a plain field, you can see you can get the ball easily. But if you see, there are houses, there are drainage systems, there are other facilities, so ball can go anywhere in this area, so it is very difficult to find that ball in that particular space. Exactly same pattern can happen while training the model. If there are many dimensions, there is a possibility that the model cannot go very much efficient. Let's say we have an e-commerce website, and in that website, if someone is going to search something, let's say grinder, you will see the related products that you see next to the grinder, let's say grinder blade or something. So if you're going to predict so if someone is going to search grinder, a lot of data of that person is being fed to the machine. Let's say username, what time it logged in, what query it hit, what is the mobile number of that user, and a lot of data it goes as a JSON payload. But to train the model and to predict the related products next to the grinder, you don't need that much of data. We have a method called PCA, principal component analysis. Principal component analysis. So what this does is it finds required dimensions that is necessary to feed the model, and those required dimensions only is being fed to the model to find the better accuracy of the model. So this is what it's very necessary to improve the accuracy of a model. So one more important topic that we need to discuss is feature engineering. Now what does is, as the name said, feature. So while training the model, we need to focus on the features. We have to give good features in order to get good results, right? So first thing is normalization or standardization. What happens? Let's say we have a column called age and we have a column called salary. So age, if you see, it starts with 18, 25, 27, 30, 40, 43, like that. But if you go to salary field, it can start with 20,000, 50,000, then 1 lakh, then let's say 10 lakh, 10,000, and let's say 45,000. Now if you see, the A's are very small numbers and the salary obviously are very large numbers. In that also, if you see, 20,000 is 5 digits, whereas 1 lakh is 6 digits. So obviously model doesn't know much difference between, because if you're going to feed the model with numbers, it's going to consider that this is a very small unit and this is a very large unit. So what are you going to do? You have to normalize this kind of inputs. You have to bring in such a way that it should fall between 0 to 1. Let's say this is going to be 0 0.2, 0 0.7, like that. If you can standardize itself, so it will be very easy for the model to understand. Now second method that we're going to discuss is one hot encoding. Now what happens in one hot encoding is, if there are text categorical data, let's say we have categories like red, blue, green. Now as you know, models are basically mathematical formulas. They don't understand red, blue, green. So we have to use in such a way that they should understand. Let's say we're going to create some encoding for this. Let's say for red, this is true, so this is going to be 1, and other field are going to be 0 0. For blue, So let's say this is blue, other things are going to be 0 0. For green, this is going to be 1 and this is going to be 0 0. Now if we'll pass this in the binary format, this can go 1 0 0 0 1 0 0 0 1 for the red, blue, green understanding of the data. Handling missing values. Handling missing values. Now what does that mean? If you're setting a data set, if there are few columns that are not being populated, it's better to drop that column. Let's say this is a primary column. Let's say this is the ID column of someone, so of a person. So ID, name, salary, or company name, let's say we have like that. So if ID column itself is empty, then other important details won't be that much necessary because you don't know the ID itself. So it's better to drop this column entirely itself in order to process, because we should not process the empty records. Now let's say we have a salary column and one salary column is empty. Let's say for a company, salary is like 20,000, 25,000, 30,000, then empty, then we have 26,000. Now if this kind of salary and this one is empty, you can see we can find an average of this salary and we can populate these records. What is the average will come? So we can go for that mean or median or mode to populate these columns, and then only we should process that records. Now next we have is feature extraction. Now what does this? Let's say we have a timestamp column. In timestamp column there are many records. Let's say we have a day, year, month, lot of details are there, right? So we can extract and create separate features out of a day, separate, we can separate year, we can separate month from that. So now let's say we have something called address column. Now from that address we can extract city, state, like that. So this can be different features, and according to our need we can use these features to train a model and to get the accuracy better. On the next video we'll talk more about neural networks. So keep studying and please subscribe to the channel.